Bharat Mata Ki Jai, Om Namah Shivaya, Jaya Shree Ram, Jaya Seetharamjayam, Nari Shakti Ki Jai, and salutations to all divine energies. Hello, good day, God bless you ladies and gentlemen. I am Sarath C, and I welcome you to the Sarath C Aviation and Rail Knowledge channel. Today, we enter into a deep and international standard level seminar documentary about one of India's most ambitious aerospace engineering challenges, the indigenous Kaveri Aircraft Engine. This will be a full feedback investigation, an advanced technical and strategic analysis, and a motivational story of India's struggle to achieve self-reliance in jet engine technology. The Kaveri engine project is not just about engineering, it is about India's national dream of powering its own fighter jets without foreign dependence. Initiated in the late 1980s under the Gas Turbine Research Establishment, GTRE, the Kaveri engine was envisioned as the heart of the HAL Tejas light combat aircraft. At that time, India's scientists and policymakers were clear: a modern air force cannot rely indefinitely on imported propulsion systems. A fighter aircraft is only as good as the engine that powers it, and without indigenous control of propulsion, true independence in aerospace cannot be achieved. From the beginning, the Kaveri project faced extraordinary challenges. Jet engines are among the most complex machines ever built by humans. They operate at extreme pressures, temperatures, and tolerances where even a fraction of error can cause catastrophic failure. For a country that had only recently entered advanced aerospace research, mastering turbine blade metallurgy, high-temperature alloys, combustion chamber efficiency, and afterburner design was an enormous challenge. Over the years, GTRE and DRDO engineers achieved partial successes and encountered repeated setbacks. The Kaveri produced thrust, but not enough. It performed, but not to the standard required by the Tejas program. Test flights revealed problems with turbine blade durability, compressor efficiency, and fuel consumption. The international feedback from aerospace specialists often compared India's progress with giants like the US, Russia, and France, where decades of research had gone into perfecting engines like the GEF 404, UL-31, or SNUCMA M88. In comparison, India was a newcomer, learning through trial, error, and persistence. From a technical aerospace seminar perspective, the Kaveri engine's architecture aimed to deliver around 80 to 90 kN of thrust with afterburner. This placed it in the medium thrust class suitable for light fighters like Tejas. The engine was designed with modular construction, a 3-stage fan, 6-stage compressor, annular combustor, single-stage high-pressure turbine, and afterburner nozzle. On paper, it was an ambitious design that matched international concepts. However, in practice, the thrust shortfall and weight challenges limited its ability to integrate with Tejas in frontline service. Now, let us turn to the feedback and operational analysis. The Indian Air Force's feedback was clear. While the Kaveri was a promising start, it was not combat ready for Tejas. Hence, HAL shifted to using imported General Electric F404 engines for Tejas Mk1, and later planned F414 engines for Tejas Mk2. This was a practical decision to ensure that the fighter program was not delayed indefinitely. However, this shift did not mean the end of Kaveri, it meant reorientation. The government, GTRE, and international partners began working on modifying the Kaveri for other aerospace applications. Feedback suggested potential use in unmanned aerial vehicles, UAVs, trainer aircraft, and marine propulsion systems. France's Safran Group collaborated with India to study ways of reviving and refining the Kaveri core. This feedback investigation showed that while the Kaveri in its original form struggled, its technological spin-offs in metallurgy, turbine blade design, and control software have strengthened India's overall aerospace capability. From a psychological and nationalistic point of view, the Kaveri project is a lesson in perseverance and humility. Unlike importing engines, building one's own jet engine forces a nation to build hundreds of sub-technologies, from high-temperature resistant superalloys, single crystal blades, and ceramic coatings, to precise computer-controlled fuel injection and combustion stability systems. Every failure of Kaveri was also a hidden success, as it added to India's knowledge base. International aerospace experts often say that jet engines are the crown jewels of defense technology. Only a handful of countries, the US, Russia, UK, France, and now China, have mastered this field. India's attempt, even if incomplete, has placed it within that circle of determined aspirants. The feedback from defense analysts worldwide acknowledges that the Kaveri is not yet operational, but it is an invaluable learning platform. From an advanced educational seminar perspective, the Kaveri project also ties into neuropsychological and biochemical stress analysis in aerospace. Engineers faced continuous deadlines, resource constraints, and international comparisons. The mental endurance, adaptability, and research-driven innovation highlight how aerospace development is not just about machines, but about the human brain under pressure. In this sense, Kaveri represents not only engineering feedback but also a case study in resilience psychology. Looking forward, the future of the Kaveri project lies in diversification. While it may not directly power frontline Tejas fighters, it is being adapted for Ghatak stealth UAV projects. It is also seen as a potential technology base for India's upcoming IMCA, Advanced Medium Combat Aircraft, where collaboration with Safran or other partners could help refine the engine to meet 5th generation standards. The Kaveri derivative engines are expected to serve both military and civil applications in the coming decades. Strategically, Kaveri also ensures that India's aerospace program does not remain vulnerable to sanctions or embargoes. When global political situations shift, imported engines can be restricted. Having an indigenous propulsion program, even if delayed, gives India a safety net. It signals to the world that India will not stop until it achieves propulsion self-reliance. Ladies and gentlemen, the story of the Kaveri engine is not a story of failure. It is a story of courage, determination, and ongoing evolution. It represents India's ambition to join the elite group of nations that can independently design and manufacture the soul of an aircraft, the jet engine itself. In conclusion, as part of this advanced international seminar documentary, we understand that Kaveri is not merely a machine but a journey of Indian aerospace identity. It may not have flown Tejas into combat yet, but it has already flown India into the next level of knowledge, capability, and global recognition. Thank you for watching this special international seminar documentary on India's Kaveri Aircraft Engine Feedback Investigation Report. I am your host, Sarath C, and you are with the Sarath C Aviation and Rail Knowledge channel. Don't forget to like, share, and subscribe. Also, support our other knowledge platforms like Sarath C Psychology and Biochemist channel and the Bharatiya LearnWise Education Foundation's Knowledge channel. More advanced aviation, aerospace, and scientific explorations are coming soon.